Hey guys, today we're doing the graphing side of 6.3, so 6.3 graphing exponential functions. We're going to do some shortcuts and we're going to get an abbreviated version of what we can do to graphing because we want to do the bare minimum. We want to be very efficient at what we're doing. So looking at this, I have it set up already for some steps that we're going to look through. In this version, we have our equation being just b to the x power, and then we'll look at what happens if we have a c value in there as well. So looking at step one, identifying where the asymptote is. Now yesterday in the video, I talked about what an asymptote is. It's that imaginary dotted line that my graph gets really, really close to but never actually hits. And we saw with the two graphs we did yesterday, the first one was just 2 to the x power, and that asymptote happened at 0. And then when we had 2 to the x power plus 3, my asymptote ended up getting shifted up to positive 3. So that c value, if I have something that is added or subtracted from my exponential term, from that b to the x power, whatever c is, that's where that asymptote happens. So when we start graphing these, we're going to start by identifying where that c value is, and we're going to graph our horizontal dotted line at that value, because that's going to take a lot of information for us that we know that's going to be where my graph approaches. After we've done that, for our exponential curve, I know yesterday we went through and did 6 different points, but really to get a good idea for what our graph looks like in terms of the steepness of the curve and where the curve happens, we only really need 3 values. So you're only going to need to graph 3 points when we're doing these exponentials, because 2 is not enough to be able to get a good idea for where the curve happens, but 3 of them is enough. Now, I'm already going to tell you which x values we should be evaluating, and it depends on what your base is. So if your base is a is a whole number, so it's a 2, it's a 3, a 4, whatever the number is. If that base is bigger than 1, you're going to want to use positive x values. You're going to plug in 0, 1, and 2. Those are going to give us the nicest, cleanest numbers. If your b value, if your base is between 0 and 1, meaning it's a fraction, like a half or a third or a fifth or whatever it is, we're going to want to use 0, -1, and -2, because that's going to end up flipping our fraction over and getting a nice whole number. We're trying to get the nicest, cleanest points to be able to graph. Once we have those, we're just connecting the dots to make a nice smooth curve. So let's go ahead and jump into number 1. We're going to actually put that plan into action. So with this is actually the exact same graph as the second one from yesterday's notes, but let's go ahead and use our shortcut for this now. So we can identify that this 3 is my c value. So that's going to be where my asymptote happens at positive 3. I'm going to go ahead and just put a horizontal dotted line right there at positive 3. That's the part where my graph is going to get really close to but never actually hit. The second part of this is finding my y values, finding my points based on our x's. Now, you could make a table if you want to. Some of us will be able to do this in our heads. Either way is fine. But I'm picking out x values and I'm trying to determine y values. Now, I'm setting this up as a 3-column table because I'm going to show my work for what's actually happening in between. So I'm plugging in 0, I'm plugging in 1, that's supposed to be a 2 here, and I'm plugging in 2 for my x value, and then I'm just evaluating. So 2 to the 0 power, we know that that's positive 1, plus 3 gives me 4, 2 to the first power is 2, plus 3 is 5, 2 squared is 4, plus 3 is 7. So I'm going to go ahead and just plot those 3 points. 0, 4, 1, 3, or sorry, 1, 5, and then 2, 7. So with those 3 points, we get a good idea for where the curve happens and how steep that curve is. So then we're just going to do our best to draw a nice smooth curve that's close to the not the AOS. I'm stuck in quadratic stuff. That gets close to the asymptote, but doesn't actually hit it, and then it goes through those points on the right side. Now, something to notice here, and even kind of more of a shortcut hack, I guess, that I usually do. Once you know where that AOS, where the asymptote is, where that dotted red line is, you could ignore the positive 3 in my equation and treat that like 0. And what I mean by that is, if I look at just evaluating 2 to the x power, 2 to the 0 power is positive 1. So 1 unit above my asymptote is where this first point was. I'm going to circle it in yellow. So 1 unit above my asymptote. 2 to the first power, so an x value of 1, was 2 to the first power is 2. I'm 2 units above my asymptote. 2 squared is 4. 4 units above my asymptote is where that other point should be. So it's kind of a way to not have to evaluate all the way through. If you can't understand, I'll re-explain a couple more times as we're going through, but that's a shortcut that I use. All right, so let's take a look at number 2. Number 2, we have a C value of -6 now, -6. So I'm going to go down 1, 2, 3, 4, 5, 6. And we put a dotted line here. Now in this one, my B value, my base, is a third. So I'm going to want to use X values. So I'm going to do my X work Y table. I'm going to use 0, -1, and -2. Because those negatives are going to flip my 1/3 over to make a nice whole number. So when I'm plugging in, I'm going to make my actual rows as well. So this is 1/3 to the 0 minus 6. 1/3 to the -1st minus 6. And then 1/3 to the -2nd minus 6. So 1/3 to the 0, that's still just 1. So 1 minus 6 is -5. 1/3 to the -1st is going to flip that fraction over. So now it's 3 to the +1st, which is just 3. 3 minus 6 is -3. And then 1/2 to the -2nd power. Well, that negative is going to flip that fraction over. So now it's 3 to the +2nd power. 3 squared is 9. 9 minus 6 is 3. So I can go ahead and plot my coordinates as they're written. 0, -5 is right here. -1, -3 is right here. And then -2, 1, 2, 3 is right here. Now this is one we haven't seen yet, because if you notice, it's curving in the other direction. So my graph is close to the asymptote on the right side, and then it curves up on the left side. And that is because of what my base is. My base being between 0 and 1, being a fraction, being smaller than 1, makes this what we're going to eventually call an exponential decay rather than exponential growth. And really for us, it just means it's curving up on the left side and it's getting close to the asymptote on the right side. Where number 1 was an exponential growth equation because my base was bigger than 1, meaning it's going to curve up on the right side and it's going to get close to the asymptote on the left. So again, reiterating how I would use this shortcut, what I would do utilizing my asymptote. Again, I can ignore this -6 once I have this red dotted line established on as being my asymptote. And I can just evaluate 0, -1, and -2. So 1/3 to the 0 power is +1. So 1 unit above my asymptote is where that first point should be. 1/3 to the -1st power, well, 1/3 to the negative first power, negative flips it over, 3 to the first power is 3, so 3 units above my asymptote is right here. And then the last one, 1/3 to the -2nd power, 1/3 to the -2, negative flipped it over, 3 to the 2nd power is 9, so then 1, 2, 3, 4, 5, 6, 7, 8, 9 units above my asymptote is where that third point should be. So it kind of avoids having to do all of this over here with showing your work for evaluating stuff and taking into account subtracting by 6 in your equation. It just makes it easier, at least for me, to be able to do this in my head. If you're not someone who does well with trying to keep things organized in your brain, don't worry about that. But I know there are a couple of you guys out there that like shortcuts and can handle those different methods in your noggin. So go ahead and utilize that if you want to. All right, a couple more. So here with these ones, we're adding in a different layer. We're adding in a multiplier in front of my base, but we don't have a C value. So with these, if I don't see If I don't see a c value, that means it happens at 0. So my asymptote is right there at the x-axis. It is the x-axis. Now, I can still plug in x values to get y values back out. Do a little x work y table. My base being a half still tells me I should be using 0, -1, and -2 in my equation. And it's still the same process. Still the same process. I have 3 times 1/2 to the 0, 3 times 1/2 to the -1st, and then 3 times 1/2 to the -2nd. And then you're just evaluating. 1/2 to the 0 power is still 1. 1 times 3 is 3. -1, 1/2 to the -1st, flipped my fraction over, so now it's 2 to the 1st, which is just 2. 2 times 3 gives me 6. And then my last one, 1/2 to the -2nd power is 2 to the 2nd power, so that's 4. 4 times 3 is 12. So I can go ahead and just plot those points. 0, 3, -1, 6, 3, 4, 5, 6, and then -2, 12, 6, 7, 8, 9, 10, 11, 12 is what I'm going to estimate right here. There we go. See what my graph looks like. So here are the things that were adjusted. My starting value, my y-intercept, ended up being +3 here, which matches what this number is. Right, in all my other ones, my y-intercept was always exactly 1 unit above my asymptote. In this case, it's 3 units above my asymptote because that a value is 3. It's always my starting value. But everything else is still the same. Okay. With number 4, once again, we've got no AOS or no asymptote given. I don't see any number added or subtracted after my exponential term, so my asymptote's going to happen at 0. And I'm still going to go through, pick out some x values, do some work, get some y values back out. My base being +3 tells me I should be using 0, 1, and 2. Those are going to give me my nicest, cleanest numbers. So -2 times 3 to the 0, -2 times 3 to the 1st, and -2 times 3 squared to be what I'm evaluating. So 3 to the 0 is 1, times -2 is -2. 3 to the 1st is 3. 3 times -2 is -6. And then 3 squared is 9. 9 times -2 is a -18. So I can go ahead and plot those points. 0, -2, 1, -2, 4, 6, and then 2, -18 is going to be like way down here. We're just going to estimate where that's at. So you can see it's steeper than usual, and the negative actually made it reflect over that x-axis. So now my graph is underneath my asymptote instead of above my asymptote. But the other rules that we know of still apply. My a value here, that leading coefficient, is -2. I am still -2 units from my asymptote for that y-intercept, so that still follows. And then looking at my y values, my base being 3 still tells me that I'm multiplying times 3 to get from one to the next in my equation, which is another thing that you could use. If it's easy for you to evaluate that first one, getting -2 for x to the 0 power, and then just going to x to the 1st is multiplying by 3, x to the 2nd power is multiplying by 3 from there. So you got all these different options on how you could evaluate. But that is it. That is it in a nutshell. That's as easy as I can make graphing. Your homework for tonight, is this worksheet. I know it says infinite pre-calculus. It's still just graphing some exponentials. You've got some that are that have a values and a base. Some of them have some c values as well. 5 and 6 are even a little bit more challenging because you have both a values and c values, where you've got a shift in your asymptote and you've got multiplier out in front, so make sure you guys are careful on those. 7 and 8 are working backwards, so now you're given the graph and you're trying to write the equation. Again, focus on what you need to know. We've got y equals a times b to the x power plus c, where c is your asymptote, b is your multiplier, and a is your y-intercept relative to the asymptote. All right, well, as always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you guys soon.